Out in the void between stars, humanity's farthest message makes his way through the universe. NASA's Voyager 1, which was launched in 1977, is the most important exploration project ever. This mission not only changed the way we think about Jupiter, Saturn, and their many moons, but it also gave us our first close-up look at Uranus and Neptune, two mysterious and amazing worlds. As you watch this movie, keep in mind that the two Voyager probes are still moving through interstellar space, which has never been visited by a human-made object before. But as they move into this unknown area, something strange is happening on board one of NASA's most famous spaceships from the 20th century. It picks up strange messages from space between the stars. Does Voyager just run into an unknown force? Are these signs from beings from other planets? And if they are they welcomes or possible threats? Come with us as we learn more about Voyager's amazing trip and the strange signals that have puzzled scientists for decades. It has been over 15 billion miles since Voyager 1 was launched, and it has been over 12 billion miles since Voyager 2. Take a moment to think about the idea that led to the creation of Voyager, its great accomplishments, and its ongoing impact. Take a moment to think about how these two probes and the things they found have influenced other missions and still do. When you have some free time, think about the far future, billions of years from now, when our sun turns into a red giant. At that point, Earth will no longer be a good place to live, and people will have fled to another stellar body, following the lead set by the Voyager missions. It's both humbling and exciting to think that the Voyagers will still be Earth's ambassadors in that far-off time. Each one a time capsule from a time when brave explorers on our pale blue reached out to the stars. Besides the scientific contributions of the Voyager mission, the probes have caught the world's attention by carrying greetings for possible alien civilizations in the form of golden records. Pioneer's 10 and 11 carried simple metal plaques, but Voyager's golden records were much more ambitious. They were full of pictures and sounds that gave future explorers a glimpse of Earth's rich culture and life. NASA's Voyager mission was one of their most big projects. It visited more planets, found more moons, and took more pictures than any other mission in the agency's history. There is a question: why were there two Voyagers? In the early days of NASA flying, systems often had problems that required safe mode, which turned off instruments until they were told to do so again. Because the Voyager trips were just flybys, strange things could cause them to miss encounters and scientific chances. So, having two spacecraft increased the mission's chances of success. The Spirit and Opportunity rovers on Mars later used the same approach. As we look back on their grand tours of the solar system, the Voyagers gave us tens of thousands of pictures and measurements that changed the way we think about the outer worlds. For example, at Jupiter, they gave us our first thorough look at how the planet's atmosphere works, showing us how the Great Red Spot rotates counterclockwise and how it interacts with smaller storms. The Voyager missions were important steps forward in space research, especially when they made the first ever observations of the outer planets of our solar system. Notably, they were the first efforts to find a faint ring of dust around Jupiter. By looking more closely at Jupiter's moon Io, they saw that it is active with volcanoes. Also, Europa's linear features suggested that there might be an ocean below the surface, and Ganymede claimed to be the biggest moon in the solar system. As the spaceship flew by Saturn, they looked closely at what was in its atmosphere and how it was put together. Titan's thick haze was seen by Voyager 1, which led to the idea that it might have liquid hydrocarbons on its surface, which was later proven by other probes. The missions also found holes and waves in Saturn's rings. Voyager 1 found 3 moons called Atlas, Prometheus, and Pandora that had not been known before. Voyager 1 kept going on its journey beyond the solar system, and Voyager 2 went in the direction of Uranus. Voyager 2 found 11 new moons and 2 rings that had not been seen before at Uranus. But some things, like Uranus's strange magnetic field and the fact that its temperature stays the same across all regions, were still hard to explain. Voyager 2's final stop, Neptune, revealed 6 new moons and rings. The probe studied Neptune's makeup and magnetic field, and it even found volcanic vents on Triton, its largest moon. In the end, both Voyagers went on a path that took them into interstellar space, crossing the heliopause, which is the line where the pressure of the solar wind meets the pressure of the interstellar medium. In August 2012, Voyager 1 officially reached interstellar space. This was proven by looking at electron oscillations during a solar eruption. This surprise finding went against what was expected because the number of electrons in interstellar space was higher than just inside the heliosphere. The date of departure was found by studying electron waves and a big drop in solar particles on August 25, 2012, which happened to be Neil Armstrong's birthday. It was 11.5 billion miles away from the Sun at this point. There is mass in interstellar space, which is the huge area between stars. Hydrogen makes up about 70% of it, and helium makes up about 28%. Both came from the Big Bang. The last 2% is made up of heavy gases and dust that are formed inside stars and then thrown into space by supernovae. Even though it's not very dense, the interstellar medium is very important because it's where stars are born, which shows how important it is in the universe. It is very important for the creation of stars that the interstellar medium has both thick and thin areas. Stars are born in these places, which are called molecular clouds or stellar nurseries. At first, the universe was made up of simple elements like hydrogen and helium, but as stars aged and went supernova, they released more complicated elements into the space between the stars. This process made it possible for stars with planets to form, which was different from the early universe, when planets didn't exist. Molecular clouds are very important to this process because they are where new stars are born. Materials in outer space are getting more complicated because of the changing elements inside stars. Because of this, worlds like Earth have formed that might be able to support life. Voyager went beyond the heliopause, which was a historic event because it was the first man-made object to explore this uncharted area that had never been visited by a spaceship or a person. Scientists were hoping to find out important new things about space travel and the basic question that has been fascinating people for thousands of years. Are we alone in the universe? We are looking for life on other planets even more since the finding of exoplanets, especially those that are about the same size as Earth and are in habitable zones. Even though there are a lot of unknowns in the Drake equation, it gives us hope that intelligent societies do exist. The Fermi paradox says that even though there is a huge chance for life in the universe, there seems to be no life at all. This makes us wonder why we haven't yet met intelligent life from other planets. Voyager 1's trip into interstellar space has given us useful information. It has shown us how strong cosmic radiation works and how charged particles from the Sun and other stars interact with each other. Engineers are still amazed by the spaceship, even though it is very old. As an interesting example, Voyager 1 successfully used its backup engines in December 2017, even though they hadn't been used since 1980. This showed how resilient they are and how they could be used for longer periods of time. We are at a turning point in the search for life beyond Earth. As technology improves, it gives us hope that one day we can find answers to the secrets of the universe. The Allen Telescope Array in California recently did something amazing. It picked up a signal from NASA's Voyager 1 probe, which was launched 46 years ago and is now hurtling toward the edge of our solar system, far beyond Pluto's orbit. The telescope, whose mission is to look for life beyond Earth, used 20 of its 42 dish antennas, each of which is over 61 m wide, to talk to Voyager 1. The telescope saved 15 minutes of data on a disk, but the type of information being sent has not been revealed. People have a lot of different ideas about what the signal means, from meeting strange forces in space to the scary idea that aliens took over Voyager 1. Some people even think that the signals are messages from advanced cultures to humans. It's not clear what these messages are, like whether they're friendly or could be dangerous. Voyager 1 is still being watched by NASA's Deep Space Network as it continues its journey about 15 billion kilometers from Earth. Its data transmission rate stays low at 160 bits per second. Despite its slow data transfer rate, the probe, which is powered by a device that turns the heat from plutonium's radioactive decay into energy, has given us a lot of useful information. But because the power flow drops by about 4 watts every year, NASA is having a hard time keeping Voyager 1 working. Priority steps have been put in place, such as turning off the heater on the cosmic ray detector, which was once very important for figuring out heliopause transit. The last 2 devices might last a few more years, but the fact that their power output is decreasing is very important. The Voyagers might only last a few years, or they could last until the 2030s if everything goes well. Still, these spaceships will keep traveling between stars even after their instruments are turned off. Voyager 1 will pass by Proxima Centauri, the star closest to us, in about 16,700 years. Voyager 2 will then do the same thing in 36,000 years. Both will keep going around the galaxy for millions of years, long after our sun and the heliosphere are gone. During their trips, these famous spaceships may send a final message encoded on golden records made of copper that has been covered in gold and sealed in aluminum. These records have sounds, pictures, and words that are meant to make you feel like you're on Earth. They were made to last for maybe 1 billion years, but how long they last depends on external factors, with space dust grains being one possible threat. Over time, dust particles could slowly wear away at the spacecraft's surfaces, making it harder to keep the objects from the Voyager mission safe. It has been thought about that the Voyager spacecraft's paths might be changed by the gravity of clouds between stars. When these huge clouds get close together and have a lot of mass, they might bend the spacecraft's path, which could lead to new paths, sometimes even closer to the center of the galaxy or farther away. So that the information on the golden records doesn't wear away too quickly, both Voyager ships carry them tucked against their bodies. It will be hard to make models of things that will happen in 5 billion years, but the Voyagers should be able to stay together at least in part. This durability lasts longer than the expected collision between the Milky Way and the Andromeda Galaxy. This merger will change the shapes of the galaxies as their spiral shapes are distorted or killed. This combination could get the Voyagers caught up in it. It is expected that the golden records on both Voyager spacecraft will still be partly intact after more than 5 billion years. During this time, the Voyagers could visit stars that are about 150 times the distance between Earth and the Sun to experience what it's like to travel through space. In particular, they might go around the edges of star systems and come across stars that don't exist yet or haven't been born yet. What happens to the Voyagers will depend on how things go during the cosmic merger. They might be pushed out of the newly formed galaxy by the crash, but they would still be in the galactic neighborhood. At this point, the golden records would mostly be in danger from high-energy cosmic rays and hot gas molecules hitting them every once in a while. In a galaxy that had changed a lot, the Voyagers would be traveling through billions and billions of years from now. By that time, most main sequence stars would have used up all of their fuel, leaving the universe dark and mostly made up of black holes and pieces of stars that used to be stars. Supernovae, which happen when these fragments crash into each other very rarely, would be the only major source of light during this time. If we think about this far-off future, the Voyager's records might help us see flashes of light in a dark galaxy that we can't even recognize. The data from these records could help us understand how the universe worked at this time. This is the last piece of information for today. Give this episode a thumbs up, subscribe, and hit the bell to get future updates. Also, let us know what you thought about today's material. Because you help us, we're driven to keep giving you good content and getting better. Enjoy your time, and we'll see you soon.